over, and the brightness or the intensity of that light from that star dips because the planet is blocking a small portion of that light. And we just look for that little blink of light from the star. That's the transit method. And it's become very popular since the early days. It has really caught up to the Doppler method in terms of popularity amongst astronomers. The great thing about this method is it tells you the size of the planet. You can calculate that based on how much the intensity drops, based on the amount of the blink. Bigger planets are going to block more light. And so you can estimate the size of the planet that way. Now, if you can use the Doppler effect to get the mass, and use the transit method then to get the size or volume of the planet, when you combine the mass and the volume, that gives you the density. And the density is really key. The density tells us what kind of planet we're dealing with. If it has a very high density, 4,000 or 5,000 kilograms per cubic meter, now you're looking at a solid planet, maybe something like Mercury, maybe something like the Earth, we don't know. Okay, if you have a very low density, then you're dealing with a gas giant. Now, in our particular solar system, we kind of have an in-between gap. We don't have a lot of in-between objects where they might have a density of, let's say, 2,500 or 3,000 kilograms per cubic meter. So we're going to have some surprises when we eventually get to see these planets up close. Right now, we have no pictures of these planets. We don't know exactly what they look like, but the density tells us the most information about it. At least it gives us a rough idea of whether it has a solid surface, it's terrestrial, or whether it's a gas giant type planet. The one big drawback of this method, unfortunately, it's a very powerful method, very accurate, but unfortunately, that star and that exoplanet have to be lined up exactly with the Earth for this to work. Obviously, if it's tilted at the wrong angle, we won't see the blink of that light. We won't see that eclipse occur. And astronomers think that only about 1 to 10% of star systems would be lined up just right with us for this to work. And, of course, we can still do a big survey and extrapolate the data and still get a good estimate for how many planets are out there with this. But it sure would be nice if we could use this for every star system, but we can't. Only 1 to 10%. That's a shame. Anyway, here's a little animation here to show what we're talking about here. Now, when you graph the brightness of a star, we call that a light curve. So you're looking at a light curve, the brightness of the light. And let's say that blue dot is a star and the white dot is an exoplanet. So every time the exoplanet passes in front of the star, there's a big dip in brightness, as you can see right here on the screen. Look at it dip right there. You'll also notice there's a second little dip. That's when the star actually blocks out the planet briefly, because that planet reflects light. Not nearly as much light as a star, of course, but when the star blocks it, when it eclipses it, it still actually has a small dip in the light there. But mostly we're looking for the big drop in light when the planet passes in front of the star. We're looking for that dip in the light, and from that we can calculate the size of the exoplanet. The Kepler mission was launched specifically for this reason, to use the transit method, the blinking method, to find exoplanets. It was launched in March of 2009, and it has been an incredible success. Absolutely incredible. Now, it's not like, let's say, the Hubble telescope. That's not its job to take pretty pictures or something like that. Its job is to use a photometer and then calculate record the brightness of the light, the intensity of the light. And so to a very fine degree, it's looking at the intensity, and as soon as it blinks a little bit, we know that there's a planet there. And it has now, its job, one of the things they hoped is that they would find Earth-sized planets, and now that has officially occurred. We've been finding Earth-sized planets using Kepler. They've actually sort of restarted the mission. It's called K2 now. They spent several years looking at the same patch of sky. Let's take a look at it. It's in Cygnus the Swan, and it's a very famous area of sky. It's near the Northern Cross. As you see at the bottom of the screen, that's an asterism called the Northern Cross. And that whole big patch of sky, not a big patch actually, that's about as big as your hand held at arm's length. That patch of sky, about as big as your hand in the sky there. And that's all they looked at for years, and looked for blinking stars within that grid. But again, now they've started a new mission with it. I was very excited that NASA chose to do that because, again, it has been a spectacular success. Later in the chapter, we will learn all about the results from the Kepler mission, which uses this really neat transit method. Thanks for listening.